Hello, my favorite freshman class once again. We had started the transition binary and my time ran out, so let's start this again, the transition binary. Again, these are your transition elements, your metals, groups 3 through 12. Again, just a reminder to have that periodic chart out in front of you. You do need it. Binary, meaning more than one element. Two elements is what we're going to be dealing with here in the transition area. When you look at these transition elements, groups 3 through 12, you can see that many of them have more than one atomic charge, or maybe, as we're going to say, oxidation state. For example, if you look at copper, atomic number 29, it has an oxidation state of 2 and an oxidation state of 1. When they have more than one oxidation state, you need to let me know which one you're using, okay? Now, yes, I know the nonmetals, there are many of them that have more than one oxidation state, but for now, with all the nonmetals, we will always go with the top oxidation state. For the metals, you need to distinguish which one you're using, okay? When you do that, you're going to be using Roman numerals. Now, this is new to some of you. Roman numerals, let me just write a few here on the side. 1, 2, 3, 4, 5, 6, 7, and 8. To my surprise, many of you are not familiar with Roman numerals, but from here on out, you need to know them. You do have to have these memorized. I will not be giving them to you. So you need to know these all listed here. 1, 2, 3, 4, 5, 6, 7, and 8. Whether it be making flashcards, you do, or however you go about knowing these, you do need to know them. So again, these are elements with more than one oxidation state, okay? We're going to use Roman numerals to indicate which one to use. It's like a recipe. If I give you a recipe and I don't tell you how many eggs I'm going to use, that's not good, okay? It may work and it may not. If I'm using 1 egg, 2 eggs, 3 eggs, I always tell you how many eggs I'm using. Well, when it comes to these transition binary compounds that we're going to be writing here, you have to tell me what oxidation state. The scientists need to know which one you're using. So if we take a look here at iron, I'm going to actually pull them all up so I don't have to go back and restart my pen like I keep doing, and I know that's annoying. I apologize. So when we look at iron, which is the atomic number 26 to find it quicker, it has an oxidation state of 2 and an oxidation state of 3. That Roman numeral right there is telling me that this particular scientist is using the oxidation state of 2. So just like we did before, I'm going to put a little 2 here. And then what is the oxidation state of sulfur? Look at the top oxidation state. It is a nonmetal. Okay, just go with the top one, please. It is 2. So just like we did before, these oxidation states are going to switch. The 2 is going to come here, the other 2 is going to come here, and it will look like this. Well, when they have the same oxidation state, they cancel each other out. Got a positive, negative charge there, cancel each other out. You will write it like this. Knowing that I'm going to, I think I have room. I was going to erase my little Roman numerals over here, but I'll keep them there for now. So now we have to say the name. Now in the name, this is the hard part that everybody seems to forget. You have to give me the Roman numeral in the name, not in the formula. This is the formula. Only in the name. Why? Because again, you need to tell me what oxidation state you're using. So when looking at this, I should know that I had to use oxidation state of 2 because they canceled each other out. Sulfur has 2, iron has 2, that's why there's nothing written there. And to write the name, I will write it like this. Iron, Roman numeral 2, and they still end in IDE, sulfide. Okay? I hope that's clear. Let's take a look at another one. The next one is iron, Roman numeral 3. Remember, there was a choice of either 2 or 3 for iron. Here, this scientist is using 3. We know that the oxidation state of oxygen is 2. When you look at that on the periodic chart, it does have an oxidation state of 2. These oxidation states switch when writing the formula. So it will look like this. And now you have to write the name. You are eventually going to be quizzed and tested on doing both. I will give you the name, you have to give me the formula, I give you the formula, or you have to give me the name. So you need to get used to doing it both ways. So in this case, I will call this, give it the name, iron. Now remember, this belongs to iron because they switched, right? So it's iron, Roman numeral 3, oxide. Still ending in IDE. These are still ionic compounds, metal and a nonmetal. Let's take a look at the next one. We have lead. Well, lead has more than one oxidation state as well, too. And here, this particular scientist chose to use 4. We now know that oxygen has an oxidation state of 2. Again, they're going to switch. So how do I write this? Pb2O4. Okay, we will eventually, I'll have you write them in the simplest form, but I am just going to leave this here right now at Pb2O4. Okay, we can also write that as PbO2, as in writing the subscripts in the simplest form. But for now, let's just stick with Pb2O4. Okay, we switched those oxidation states. The 2 is now after the lead, the 4 is now after the oxygen. But now I have to write the name. Now write in the name, don't forget, this 4 belongs to oxygen, or excuse me, belongs to lead, correct? So you have to tell me that in the name. Again, you look at lead, it has more than one oxidation state on that periodic chart. It has a +4 or a +2. So tell me which one you're using, and we will go with lead, Roman numeral 4, oxide. Still ending in IDE, it is an ionic compound. Let's take a look at the next one. We have tin with a Roman numeral of 2. I'm going to put a little 2 there. Again, I think that clarifies things and alleviates mistakes. Chlorine has an oxidation state of 1. We'll go with that top oxidation state of chlorine. Chlorine has like 4 different atomic charges going on there, okay? So don't get confused with it. On the nonmetals, please just go with the top oxidation state, atomic charge. Remember, that's what we're calling it. These guys switch. We don't write the 1, remember? We don't have to write the 1. You can and then erase it, if that makes you feel better. Okay, so here we have tin chloride. That 2 does belong to tin, so when writing that name, please don't forget that. That's what everybody forgets. They'll give me a tin Roman numeral 1, or they'll give me Roman numerals with the nonmetal. These Roman numerals only go with the transition metals that have more than one oxidation state. Tin, Roman numeral 2, chloride. Last example I have here. Lead, oh, it's the same, so we really don't need to do that. I'll just erase that right there. Okay, so when you look at these, we're going to get to the point, if I give you just the formula, like let's say I just gave you Fe2O3, the first thing you want to do, distinguish, is an ionic or covalent compound. Once you establish that it's an ionic compound, let's say I just happened to write this down. Oh, here we go down, sorry. Say I have this written down all by itself. And I said, please write me the name. The first thing you would look at this, is it ionic or covalent? Because with covalent, we'll start using prefixes. This is a metal and a nonmetal, so bam, right away, you know it's an ionic compound. Then step 2, look at the metal, not the nonmetal. Does it have more than one oxidation state? When I look on the periodic chart 10, it has more than one oxidation state. I know they use 2 because the choices are only 2 or 4 when you look at your periodic chart. 2 or 4 are the only 2 possible oxidation states you could use. So I know they use 2 because I see a 2 here. And I know chlorine's 1, and that would be there. So when I write the name, I know now, okay, I have to give a Roman numeral because there was more than one oxidation state. Got to give me that recipe. Which one did you use? You've got to clarify that in the name always. And you would write it just like we did. I'm writing it again, I know. Tin, Roman numeral 2, chloride. Now, there will be times I give you just the name, tin 2 chloride. And you have to give me the formula. Now you see the Roman numeral there. You know it's an ionic compound. You know that tin has an oxidation state of 2 now. So what I would do right away on the name even, I'd put a little 2 here because I know 2, that's the oxidation state of tin. I'd quickly look at chlorine, know that that has an oxidation state of 1, and then I would write it. I would switch those oxidation states and make it all simple and clear. Okay, I hope that's very clear to you. I wanted to finish up that transition binary compounds there. If you have any questions, make sure you bring it to class tomorrow, okay? We'll be working on some worksheets in class. I don't have to take up the time lecturing this. We'll just work on them, and we'll do many, many, many examples. Running out of time here, so my next video will actually be in writing formulas and naming the compounds. Again, we'll go over a few more examples of that. But for now, goodbye, and I will see you soon.